We've talked a lot about remyelination, the recovery of the myelin sheath around the nerves. But we've also said that if the nerves themselves are gone, remyelination's not really going to do all that much good. But one of you pointed out to me that there is some research in the pipeline that's looking not only at remyelination, but the actual regrowth of nerves. We have got to take a look at that. Well, hello, and welcome to another episode of You and Me and Multiple Sclerosis. My name is Pam. I've been living with MS for 41 years. And when one of you pointed out to me that there was research going on in a compound called NVG-291, I originally thought, oh, okay, more remyelination research. And that was exciting enough, but when I looked into it more, I see that they're looking at this right now for recovery from spinal cord injuries. That's what the clinical trial has been focused on right now. And they're looking at actually regrowing the neurons in addition to recovering the myelin. Quite amazing. And they've done some animal studies with our good friends, the mice, as you will see. And there are some pretty promising results. Nice to also find that so far the side effects are pretty minimal. Wow. I mean, almost too good to be true, honestly. But I will go through with you the information that I found on the NerveGen Pharma website. NerveGen Pharma is the company that is offering this product and hoping that it will make it through the clinical trials. I also have part of a video from Dr. Brandon Bieber, who talks a little bit more about the science, and I have to admit, a lot of that part I left out of this video, and you can look at it. I will put the link in the description below, but I didn't play all of that. I tried to focus as much as I could on what might be promising for multiple sclerosis, but I think you're going to have to extrapolate a little bit. If it works for spinal cord injury, the chances are really good, though, that it might actually do some good for multiple sclerosis. So let's look into this a little bit more. I thought we could just look at the NerveGen Pharma website because it's got some information about NVG-291, and that would be worth looking at for sure. Here's their general statement about their technology. The nervous system is a complex network of nerves and cells that carries messages to and from the brain and spinal cord to various parts of the body to take in sensory information, process information, and control movement. Damage to the nervous system can result in disruption to any or all of these functions. It has been the institutional belief that the nervous system is incapable of repairing itself. We know this not to be true. At NerveGen, we've changed the way people view nervous system repair with NVG-291, our lead drug candidate. NVG-291 is the first therapy in clinical trials having demonstrated the ability to enable the nervous system to repair itself, including increasing function, independence, and quality of life in individuals with chronic spinal cord injury up to 10 years after their injury. And I guess I'd just like to comment here. It's true that the nervous system can repair itself to a limited extent. But if the damage is extensive, and traumatic injury would be one way that might happen, or if it's happening repeatedly over a long enough time, as in the case of multiple sclerosis, the body really can't keep up. The body cannot do enough to repair itself. So what these folks are proposing is that they now have a way for the nervous system to repair itself. So let's find out more about that. By way of introduction, they have a small write-up here about the man who first developed NVG-291. So I'll go ahead and read this. NerveGen's lead drug candidate NVG-291 was developed in the laboratory of Dr. Jerry Silver. Dr. Silver was a renowned spinal cord injury and regenerative medicine researcher and professor of neurosciences at Case Western Reserve University in Cleveland, Ohio. Dr. Silver's research focused on why the central nervous system could not repair itself after trauma. He successfully identified an inhibitory class of molecules known as chondroitin sulfate proteoglycans, which are upregulated in lesions occurring from spinal cord injury as well as other forms of neurologic trauma or disease. And here on the site is some general information about NVG-291. In 2015, Dr. Silver and his team at Case Western Reserve University identified NVG-291, a 35 amino acid peptide. In independent laboratories and institutions around the world, the rodent analog of NVG-291 has been shown to promote nervous system repair and improve functional recovery in preclinical models of nervous system damage and neuroinflammation. A list of select scientific publications that give an overview of the robust effect of NVG-291R seen in animal models is provided in our list of journals and publications. We'll take a look at that in a bit. NerveGen's lead drug candidate is NVG-291, is a first-in-class 35 amino acid peptide administered by subcutaneous injection under the skin to relieve the inhibitory effects of CSPGs to enable the nervous system to repair itself. Now let's take a look at this section of the website under Pipeline. They're looking at a number of different things related to nerve damage: spinal cord injury, stroke, Alzheimer's disease, and multiple sclerosis. And of course, we want to go check out what they have to say on multiple sclerosis, so let's go ahead and do that. And by way of introduction, they say that multiple sclerosis is a chronic disease in which the immune system attacks myelin, the fatty coating around neurons in the brain, optic nerves, and spinal cord, impairing signal transmission and potentially resulting in loss of neurons themselves. Approved disease-modifying drugs modulate the immune system, which may reduce relapses and slow disability progression, but, and I put the but in there myself, there are no approved drugs that can promote repair and improve function. And we know from other work that I've covered on this channel, there are many options in the pipeline right now for looking at that very thing. But it is true, there's nothing out there that's available in the clinic that's been proven to be effective for humans. And going down a little further, they talk about multiple sclerosis and NVG-291. In multiple sclerosis, scar-like plaques called lesions form in areas of the brain and spinal cord where myelin is damaged. Although remyelination can occur spontaneously, it ultimately fails in the areas where lesions develop. These lesions are associated with molecules called chondroitin sulfate proteoglycans, or CSPGs, which might initially help to contain the damage, but in the long term, the interaction of CSPGs with their cellular receptor, protein tyrosine phosphatase sigma, or PTP sigma, interferes with the repair of damaged myelin. In animal models, NVG-291R relieves the inhibitory effects of CSPGs, and thus, NerveGen's lead drug candidate, NVG-291, is expected to enable neural repair by promoting formation of myelin and improving connections among neurons. So this is what's exciting about this research in particular. We've looked at a lot of remyelination therapies, but this one purports not just to do that, but to actually stimulate the regrowth of neurons and actually give back nerve function that's been lost. Pretty amazing. And in fact, they go on to say in this last paragraph, in an MS model, animals treated with NVG-291-R had substantially greater remyelination compared to placebo-treated animals after 21 days, and NVG-291-R restored motor function even when administered after symptoms were fully developed. And they link to a paper which we may or may not see in a bit. So in summary, in animal models of MS, NVG-291-R has been shown to stimulate the production of oligodendrocyte precursor cells, allow remyelination and regeneration of damaged neurons, increase specific proteases that digest and break down the glial scar tissue, CSPGs, that otherwise keep neurons from regenerating and oligodendrocytes from remyelinating. A list of select scientific publications that give an overview of the robust effects of NVG-291-R seen in animal models is provided in our list of journals and publications. Might as well click on that and see what we get. And then they talk about their publications in scientific journals. They say that this is our data center where we list selected publications in scientific journals. Links to the publications will be included when allowed by copyright law. In reviewing these publications, it is helpful to note that our lead drug candidate, NVG-291, is the human analog of NVG-291-R, which has been used in most experiments in rodents. NVG-291-R is also most commonly referred to in the literature as intracellular sigma peptide, or ISP. Please note that this is not a comprehensive list of all publications related to the identified topics. The same article may be present in our list under multiple headings if it relates to multiple subjects. There may be scientific publications relevant to any of the listed topics that have not been identified by NerveGen or that have not been included in this website. And we are not going to look at every single one of these, obviously, but I just wanted to show you there's quite a few publications related to this work that have already been put out there. And it looks like a number of them have links. You might be able to go out and see at least the abstract. Sometimes they don't let you see the whole paper unless you subscribe to the journal. But maybe you can get it through a library or some other way. But yeah, you see a lot of different publications. And then there are articles about CSPGs and damage to the nervous system. And the articles tend to be more targeted at an educated lay public, if you will, so that if you know a little bit about basic science, you can get a lot out of these articles. So these also might be something worth taking a look at. And then they've got selected articles relevant to their work, specifically NVG-291 and spinal cord injury. And then they've got articles related to NVG-291 and stroke. And they've got NVG-291 and myelination, which is a big one for us with MS. We're very interested in that, so there's several things that have been published along those lines. And there's articles that are relevant to NVG-291 and Alzheimer's disease. And there are articles that are relevant to NVG-291 and other diseases. So there you go. There's lots of different applications that they're looking at for this particular compound. And just to go down further, here's the general information about NerveGen Pharma. And they're a clinical stage biopharmaceutical company developing first-in-class neuroreparative therapeutics for spinal cord injury and other traumatic and neurologic disorders. NerveGen's lead candidate, NVG-291, is the first and potential best-in-class candidate being evaluated in the Phase 1b/2a CONNECT SCI study in individuals living with spinal cord injury. And they're located in Vancouver, British Columbia. So there's contact information and all kinds of stuff that you can follow up on if you so choose. We also should take a look at this section of the website where it says under pipeline, NerveGen's lead drug candidate, NVG-291, is a first and potential best-in-class 35 amino acid peptide targeting the inhibitory mechanisms associated with chondroitin sulfate proteoglycans. NVG-291 is being evaluated in the phase 1b/2a Connect SCI study, where the therapeutic peptide demonstrated the ability to increase function, independence, and quality of life in individuals with chronic spinal cord injury up to 10 years after injury. NerveGen is also evaluating a discovery lead, NVG-300, in preclinical models of neurotrauma and neurologic disorders. And so let's just scroll down here to see that table. And as you can see, NVG-291 is currently being trialed for traumatic spinal cord injury, and there's preclinical work being done in traumatic brain injury, traumatic hearing loss, and stroke. But they also have another compound, NVG-300, which is in preclinical investigation for stroke. But they're looking, too, at amyotrophic lateral sclerosis, Alzheimer's disease, and multiple sclerosis with that particular compound. And these are further behind. They're not nearly as far along as they are with the spinal cord injury. But the results of that are quite promising. And something tells me that if it's beneficial for an injury, then it's likely also to be beneficial for damage that's caused by a disease like multiple sclerosis. Here are the portions of the video from Dr. Brandon Bieber that I thought would add to what we've already been seeing on the NerveGen Pharma website. Bear in mind that this video came out in October of 2024, so it's not up to the minute. But what he says, I think, is still very valid and useful for us in considering whether this is something that we should be tracking.
This mouse with a spinal cord injury has extraordinary improvement after receiving the investigational drug NVG-291 being purported to treat multiple sclerosis, spinal cord injury, and even other neurological diseases such as Alzheimer's disease. In this video, I'll explain the pathophysiologic basis of the drug, some of the early basic science and animal research, and even early clinical trials in humans. Citations below. Unlike what was believed decades ago, the nervous system does have some capability to grow, repair, sprout new axons, form new synapses, but after an injury, a scar can form. This is a section from a spinal cord in a rat with a traumatic spinal cord injury showing extensive fibroblast cells of the connective tissue forming an impressive barrier that can prevent repair. Research has shown that within the extracellular matrix of the area of injury are these compounds called chondroitin sulfate proteoglycans. You may recognize chondroitin sulfate, the popular supplement you take when you have an orthopedic injury. And these are chains of glycosaminoglycans that have sulfur groups attached to a core protein, and they form these large continuous structures that may impair normal nervous system repair after an injury and may block the sprouting of axons or nerve fibers. This diagram shows an area of injury. You see a neuronal cell body and some sprouting axons, and in red are represented the chondroitin sulfate glycosaminoglycans, and they don't just form a physical barrier, they also have a chemical interaction with a transmembrane receptor on the sprouting axons called tyrosine phosphatase sigma, or PTP sigma, and this interaction actually signals the sprouting axon to stop. In other words, it inhibits neuronal growth. You may wonder, why would this occur? It's thought to be important in embryonic development to prevent nerves from growing in areas where they're not supposed to be, or to force nerves and axons to grow in a certain direction. And the theory behind NVG-291 is there's just too much of this inhibitory sigma signal at the site of injury, preventing axonal sprouting. And it turns out these chondroitin sulfate glycosaminoglycans are everywhere. This is from a cervical rat spinal cord injury. The neural components are stained in green, and the glycosaminoglycans are stained with the WFA stain in red. And you can see it's very extensive, forming a net around the neurons, and so it's really blocking neuronal growth. By the way, my name is Brandon Bieber. I'm a clinical neurologist. I don't normally read a lot of spinal cord injury basic science and animal research, and I apologize for any inaccuracies in this presentation. But let's move on to animal studies, and we'll start with multiple sclerosis. These are slides from a study in experimental autoimmune encephalomyelitis, a mouse model of multiple sclerosis where mice are exposed to lysolecithin, a myelin toxin, and then allowed to recover. On the left, we see the placebo group treated 3 days, and then we see 21 days after the injury. These are pathological sections from sacrificed mice, and this is a myelin stain where the myelin stains dark blue, and the NVG-291 group is on the right, treated and then 3 days and then 21 days after the injury. You can see the placebo-treated mouse has a large area of myelin loss where there's almost no injury in the mouse that's treated with the drug. Of course, that could be a cherry-picked slide. So here we're looking at all the data. We're looking at lesion volume in the y-axis. The blue is vehicle or placebo. You can see the lesion size increases after injury and then shrinks down as repair naturally occurs even in the placebo group. But there's much more repair and a much smaller lesion in mice treated with the NVG-291 compound. This is electron microscopy looking at a cross-section of the nerve fibers in a sacrificed mouse treated with intracellular sigma peptide or NVG-291 on the bottom. Much more impressive myelination than the mouse treated with placebo on top. And it's known that chondroitin sulfate glycosaminoglycans are present in multiple sclerosis plaques in humans, so perhaps this drug could be effective for humans with multiple sclerosis, although there's no ongoing phase 1 or 2 trial in humans quite yet. We don't know too much about the potential side effects of NVG-291. This is a phase 1 trial in humans, so the drug was given to healthy humans, humans without multiple sclerosis, without spinal cord injury, and some had some injection site reactions, irritation at the site of injection. There was an increased rate of headaches, 25% in the treated group versus 15% in the placebo group, but no serious side effects, though the sample size is quite small, so we don't know about rare serious side effects. I think this is really exciting research. I give a ton of credit to the basic science and animal researchers who developed this technology over many decades, most of the studies which I didn't mention in this presentation. Of course, even after the phase 1B trial is completed, there will have to be a phase 2 and phase 3 trial, so it will be quite a while until this drug is actually on the market, even if it's proven to be effective.
Okay, well, that's enough to chew on for a while, I would say. It's pretty neat. It's maybe the first one I've seen where they are talking about not just remyelination, but the actual regrowth of nerve tissue. I'm not quite sure how that works. I think, once again, the less damage you have, whether you're talking about spinal cord injury, multiple sclerosis, or Alzheimer's, or anything else, the less damage you have, the more likely there will be recovery. It only makes sense, right? But I am interested in this. Seems to be a novel direction for things to be going, and the mouse models so far look really good. If those videos are at all reflective of the kind of results we might see in humans, that would be a wonderful thing. So I will keep an eye on this from now on, and thank you again for my viewer that pointed this out to me. I really do love it when you guys suggest things to me. I follow them all up, and some of them I make videos about if I think they're of general interest to the channel, and sometimes I don't, but I'm always grateful to know what's going on out there in the world of research on multiple sclerosis and related neurological disorders. There is so much going on. It's quite impressive, and I think we should be encouraged by that. And I've said that to a number of you. It's very encouraging just to see the extent of the research, the number of teams, the geographical distribution of the teams, the approaches that they're taking to figure this problem out. I really want to see more happen, and I want to see it happen in my lifetime. So let's just keep an eye on it and do all we can to encourage it. Talk to your neurologist about it. See what they know. It would be good to see some of this, see the light of day and make it into the clinic. But patience is going to have to be our watchword once again this year, just as it has been in years past. Now, I know that the spinal cord application of the NVG-291 is being fast-tracked by the FDA because they do really want people to have access to it. So when they start looking at multiple sclerosis with NVG-291, if the results are anywhere near as promising, they may fast-track that as well, and that would be great. Is that something that you would be interested in signing up for if that were possible? Let me know in the comments. But that is all I have for you today, so until my next video, keep taking really good care of yourself, and I will see you again soon.